Hi there, hope you have a fantastic day today. This lesson I will teach you how to integrate trig functions. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First of all, we need to know that if we integrate sine of x will give me negative cos of x. So let me just write this down. So if I integrate sine of x respect to x, which is equal to negative cos of x. Of course, we need to plus a constant because of indefinite integrations. So we add a c. And we also need to know that if we integrate cos of x, will give us sine of x. So if I integrate cos of x dx will give me sine of x add a c. Because we differentiate sine will give us cos. And if we integrate sec square of x will give us tan of x. So let me just write this down. Integrate sec square of x will give me tan of x and add a constant. So please take note on this, okay? So let's just go through first example. So first one, so we need to integrate cos of 2x plus 5. So we just need to go through this process. So step number one, we need to know that if we integrate cos of x dx will give us sine of x and we add a constant. So now, first of all, what we do, we integrate cos first. So to integrate cos, we know that becomes sine. So we just write this down. So that will give us sine of the whatever that angle is. In this case, the angle is 2x plus 5. So let me just write this down. Sine of 2x plus 5. So that is done. Then what we do, we just need to differentiate the angle. So if we differentiate this angle here, 2x plus 5 would differentiate that will give us 2. So instead of time, we just divide by 2. Divided by 2. And don't forget, we need to add a constant. So there you go. So this can be also written as this form. So that is exactly the same as a half sine of 2x plus 5. We add a constant. There you go. Second one. So we need to know if we integrate cos of x dx will give us sine of x. Add a constant. So the step number one is we need to integrate the trig first. So integrate cos, give us sine. So let me just write this down. So that is equal to sine of the angle. We just write this down. The angle in this case here is a half of x plus 3 or x over 2 plus 3. And then what we do, we differentiate the angle. So differentiate this. So a half of x plus 3. So remember, x over 2 plus 3 is exactly the same as a half of x plus 3. So keep that in mind. So if we differentiate that, so let's say we can write y is a half of x plus 3. We differentiate that, give me a half, right? So therefore, we just divide by a half. Divided by a half is like this. Or this is exactly the same as we flip the fractions a half. So it becomes times 2 over 1. So therefore, we know that 2 over 1 is 2. So just 2 times that. What I do, I just simplify this. So this 2 over 1 is same as 2. So the answer is 2 sine of x plus 2 add 3. And don't forget, we need to add a constant because this is indefinite integrations. So I add c here. So I add c here, okay? So there you go. Third one. So integrate sine of 3x, okay, respect to x. So first of all, we need to know integrate sine of x will give us negative cos of x. So negative cos of x. And don't forget the constant, okay? So now what we do with first step is we integrate the trig first. So integrate sine will give us negative cos. So let me just write this down. So negative cos of the angle. So in this case, the angle is 3x. So I just write this down. So that's the first step done. Then what we do? We differentiate the angle. So differentiate 3x, give me 3. So instead of time, we divide because we do opposite of differentiations. So when you differentiate trig, we time by the differentiate of the angle. But when you integrate trig, so what we do, we divide by the differentiate of the angle. So differentiate of the angle is 3. So we just divide by 3. And then don't forget, we need to add a constant. So there you go. But this is exactly the same as negative 1 over 3 cos of 3x add a constant. So there you go. Fourth one. So first of all, we need to know if we integrate sec square of x, this will give us tan of x. So tan of x, and don't forget, we need to add a constant. So therefore, step number 1 is we have negative here. So instead of just integrate straight away, what I do, I can just take the negative out. I can write like this as well. So this is exactly the same as sec square of 2x plus 5 dx. So the negative, I just write this down. Now what I do now is I integrate the trig. So sec square, if I integrate that, it will give me tan. So I just write this down. So tan of the angle, that is 2x plus 5. And don't forget, we need to differentiate the angle. So differentiate the angle here, it give me 2 because 2x plus 5. So differentiate that will give me 2. So instead of times 2, I just divide by 2. That's all. So I divide by 2. And don't forget, we need to add the constant, that is c. So now I can also write like this because over 2 is just same as a half. So that is equal to negative 1 over 2 tan of 2x plus 5. And we need to add a constant. So there you go. Please pause the video and try this one yourself. Hi there, I'm back. How did you go? So let me go through them with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. First one. So first of all, we need to know that if I integrate sine of x dx is equal to negative cos of x plus c. So now we know that 3 in front here, it is a constant. So I can write this out, okay? So I can just take it out. So this is exactly the same as 3 integrations of sine of 4x dx. So now I integrate trig. So the sine, it becomes negative cos. And the 3, we just write this down because 3 is just a constant. So 3, we times. So integrate sine, give me negative cos. So minus cos of 4x because 4x is the angle. So I'm done with trig. So what I do now is I differentiate the angle. So differentiate 4x will give me 4. So instead of times 4, we divide it by 4. So that is over 4. And don't forget the constant. So now what I do, I just simplify. So that will give me negative 3 cos of 4x over 4 plus c. Or you can write as negative 3/4 of cos 4x at a constant. There you go. Question number 2. So we need to know integrate of cos x will give me sine of x. So just write this down. Integrate cos of x is equal to sine of x and add a constant. Because we differentiate sine will give me cos. Okay, keep that in mind. So now, and that will give me the 5 is we can just take it out. So you can make it easier, simpler. You don't have to, but you can take it out. So cos of 6x minus 7 dx. So that will give me, so the 5, I just write it down because it's just a constant. So now I just integrate cos, give me sine. Sine of the angle, that is 6x minus 7. Now we just differentiate 6x minus 7. So that gives me 6. So now we just divide by 6. Okay, we divide the differentiate of the angle because we integrate, not differentiate. Okay, so I divide this by 6 and we add a constant. So there you go. So I can also write as 5 over 6 sine of 6x minus 7 at a c. You can write like this if you like, or you can leave it in this form. Still perfectly correct, okay? Now, part 3. So first of all, let me just take the 2 out first, okay? Makes it easier, that's all. So sine of 1/5 of x. So we know that if we integrate sine of x, this will give me negative cos of x. So become negative cos of x. So now we, first of all, we need to write the 2 down. The 2 is a constant. And then we times by, we integrate sine. Give me negative cos. So we times by negative cos of 1/5 of x. And then what we do, we differentiate the angle. So differentiate 1/5 of x will give me 1/5. And then we divide by 1/5. So if you divide by 1/5, it's exactly the same as times by 5 over 1. We flip the fraction, remember? So what I do, I just simplify this. So we have negative times a positive, give a negative. So minus 2 or negative 2 times 5. So give me negative 10. Because over 1 still give you negative 10. So negative 10 and then cos of 1/5 of x. You can bracket the angle if you like, and then we add a constant. This is at a constant. So there you go. Second last one. So we need to know how to integrate sec square of x. So that will give us 10, right? So let me just write this down for you. So integrate sec square of x will give me 10 of x at a constant. So now what we do, we just integrate the trig first. So this one will give me 10. So that is equal to 10 of the angle 5x minus 2. And then don't forget, we need to differentiate this. Give me 5. So instead of times by 5, we divide it by 5. So we just do opposite of differentiation. So instead of time, we divide. So there you go. And don't forget, we need to add a constant. So that is your answer. You can also write, if you like, 1/5 10 of 5x minus 2. So there you go. So you can either live in this form or this form. Still correct, okay? Last one. So let me just take out negative 2 first, okay? So this is negative 2 integrate, because this 2 we take it out. So we left with cos of 1/3 of x at 4. And of course, this is dx. So now what we do, we need to know that if we integrate cos of x, will give us sine of x. So now what I do, I just write down the negative 2 down because that is just a constant. So write minus 2. And then what I do, I integrate cos. So that will give me sine. So I write this down. So sine, so 1/3 of x plus 4. And don't forget, we need to differentiate the angle. So if we differentiate 1/3 of x plus 4, that will give me 1/3. And then we divide by 1/3, okay? Not times, because we're doing antiderivative, if you like. So instead of time, we divide. So if we divide by 1/3, we flip the fractions, become 3 over 1. And we times 3 over 1. And don't forget, we need to add a constant. So c. So now what I do, I just simplify this. So negative 2 times 3 give me negative 6. So that is equal to negative 6. And we just need to write down sine of 1/3 of x at 4. And don't forget, we need to add a constant. So there you go. I hope you got all of them correct, and thank you so much for watching. Bye.